Hello and welcome to the revision session for Wednesday the 5th of December. We're going to have a look today at the conduction system and we're going to link that in with cardiac control. So we're going to have a look at the electrical stimulation of the heart and followed by how that stimulation is controlled by the cardiac control centre via the various receptor systems that we have around our body to inform that control centre of what the conditions of the body, exercising or not, are. So it should be quite an interesting one, should be quite relevant because lots of this material can come up in different types of questions as well. And we will be following this session up with a subsequent one on the cardiac cycle of the heart, how the blood itself flows through the heart. So first of all, most important thing, this is the conduction system. So if you see that term in your question, that is the trigger for you to get this information we're going to go over now down on that page. If conduction system is in the answer, get this material down. First of all, we sometimes have to do it in order. So we're going to start here with a number 1 by the term sinoatrial node. That is to say that the heart electrical impulses, or its electrical excitation, is controlled by the sinoatrial node. This is part 1, the first stage of the contraction of the heart. Of course, we call contraction systole. So here we have our SA node, and as you see from the arrows that are already there, this SA node emits a signal across what we call the atria, not the ventricles, but the atria. Okay, and as a result, the atria, as they are electrically stimulated, are stimulated to contract. So number 2, I'll put it down here, is what we call atrial systole. Okay, you can say contraction, but try and use the term systole if you can. So the sinoatrial node emits its impulse and it triggers atrial systole or contraction, which of course forces the blood down out of the atria into the ventricles. Now the second job that the SA node completes is it does a, whoops, that wasn't what I meant to do, put that back there. It produces a signal which stimulates this part of the heart, which we call the AV node. So here's number 3. The AV node is stimulated by the sinoatrial node. We can actually see here, just draw it a little bit thicker, this line here is contacting the AV node from the sinoatrial node. It is exciting the AV node to emit a second impulse. And as you can see already, that second impulse from the AV node, our third stage, comes down here. Now down here is what we refer to as the septum of the heart. Okay, notice I'm not numbering that, it may not actually get you a mark, the septum of the heart, the separating wall in the middle of the heart. Now, at this point here, which I'll identify in orange, the signal is separated into 2 branches, and this is achieved by point 4, which we call the bundle of His. Just in there, the bundle of His. The job of that bundle is to separate the signal into 2 signals down the septum of the heart, and of course those 2 signals ultimately are going to surround the 2 ventricles, as we can see here, and those surroundings, they of course emit the impulse down through the septum, down to the apex of the heart, which is this part here, and then the excitation travels up the heart. So if you like, the contraction of the ventricles then happens in this direction, forcing blood up and out of the heart. So, point 5 is that the 2 separate signals achieved by the bundle of His are then separated into many, many different signals in these little kind of spiky fibres over here. Okay, so it gets to every single muscle cell within the heart, and this is achieved by some specialist fibres called the Purkinje fibres, which are down there, and that is point 5. And when the Purkinje fibres emit the impulse to every cell of the ventricles, we of course achieve, try and write it small because I haven't got much space, ventricular systole. And that ventricular systole, or ventricular contraction, looks a bit like an O, make it an E. That ventricular systole forces blood up and out of the heart. So, for example, from the left ventricle, we can see that the blood would go flying out of here, past the semilunar valve, up around the aorta, and then to the rest of the body. So that is our 6th stage in this process. So the big question I hear you asking is, what controls the sinoatrial node? What speeds up and slows down the sinoatrial node? So we'll come to describe that right now. We're now going to have a look at how heart rate is controlled and how the sinoatrial node receives itself stimulation from the cardiac control centre, which we will refer to as the CCC up there, how the SA node receives information from that cardiac control centre. First of all, we're going to have a look at what we consider to be neural methods of controlling heart rate. First of all, we have an image here which helps us with the first one. We see in this phrase here that baroreceptors that exist, really for us we're interested in this aortic arch here, they receive information, or they sense information about the condition of blood pressure in that aortic arch, and they inform the cardiac control centre in this way about the conditions of that blood pressure. If that blood pressure has risen, then of course we get a sympathetic stimulation, or a stimulation of the sinoatrial node which increases heart rate. So baroreceptors do that job. We also, so there's our baro, I'm going to put that in there, baro. We also have exactly the same thing which occurs via our chemoreceptors. If chemoreceptors which exist in arteries, if they sense a drop in pH level, or the blood has become more acidic, again they stimulate the cardiac control centre in exactly the same way as you mentioned before, and we get a sympathetic stimulation of the sinoatrial node, increasing heart rate. Of course, if it's the end of exercise and we are recovering, the opposite, because baroreceptors sense a decrease in blood pressure, chemoreceptors sense an increase in pH. Thirdly, we also have a system called our proprioceptors. Proprioceptors sense changes in muscle and tendon tension. So if we are moving, the tension of those muscles and tension increases, and of course then the cardiac control centre again sympathetically stimulates the SA node. If it's a decrease in tension because we stopped running, moving, jumping, playing sport, we get a parasympathetic stimulation of the SA node, and we get a decrease in our heart rate. So that describes our neural control. We also need to know that we have a different system called hormonal control. Really simple system this. When we experience that excitation of being about to exercise, we often call this the anticipatory rise, for example, we emit a hormone called adrenaline, which acts directly on the sinoatrial node. I choose a different colour to do that. Oh, no I didn't. Which acts directly on the sinoatrial node. Adrenaline. And that adrenaline stimulates the SA node, and we get an increase in heart rate. So if we are expecting to exercise, or if something exciting happens, we experience this rush in adrenaline which increases sinoatrial node activity, and we call this up there hormonal control. So look for that term in your question. It's asking about neural, hormonal, or perhaps even our final one, which is intrinsic control. Now then, intrinsic control again is a very simple system, and that is to say that when the heart itself becomes warmer and more stretched because it is working more, we've got an increased venous return, for example, so we have an increased ventricular filling which stretches the heart, makes it work harder, increases temperature. We have thermoreceptors and stretch receptors in the heart which actually sense those conditions, and they can then impact on the SA node, and again we call it sympathetic or parasympathetic. Sympathetic increasing stimulation, parasympathetic decreasing stimulation, and of course therefore we end up in a situation where the heart rate itself changes. So I've now added to this session 2 questions that you can consider answering. First of all, describe the heart conduction system. Really simple.
4 marks. I'll explain what I want from that in a moment. And secondly, explain how heart rate is controlled by neural factors. So give yourself 5 minutes and answer those. And when you're ready, press pause now. When you're ready, press play again. I'll explain the answers. So the answers to question 1 would come from that first period of teaching I talked to you about. 6 marks on the mark scheme. Mark 1 would be the sinoatrial node emits an electrical impulse across the atria. We then experience atrial systole, which is point 2. Point 3, the AV node is then excited or stimulated. Point 4 is that the signal from the AV node is split by the bundle of His. Point 5 is that the signal is then further split by the Purkinje fibers. And point 6, we experience ventricular systole. And explaining how heart rate is controlled by neural factors. So you get nothing here for things like adrenaline. You get nothing here from the intrinsic control of the heart. You could replace that word in the question, of course, and look at a 1-2 mark question on the other 2 examples. But you must have said that during exercise, if blood pressure goes up, if pH level goes down or acidity goes up, and if movement tension in muscles and tendons goes up, then we have an increased stimulation of the sinoatrial node by the cardiac control centre, and this is referred to as sympathetic stimulation. Thank you for listening, and I'll see you tomorrow.